All right, so today is going to be our second lesson on probability, and you can see the title. We're going to be talking about probability of multiple events, and for us, multiple means two events. So in order to understand today's lesson, we need to identify some terminology because this is going to be pretty important for the rest of the lesson. We need to understand what we mean by dependent events. And I've just given you some fill-in-the-blank here definitions. Dependent events, that refers to when the outcome of one event affects the outcome of a second event. And in just a little bit, you're going to get some examples of this, and I think it'll help the definitions to become a little bit more clear. But we have these dependent events where the first outcome affects the second. Then we have independent events. You can probably guess what this is all about. This is when the outcome of one event does not affect. There is no effect whatsoever on the second event. They're completely independent. And then in the second half of the lesson, we're going to talk about what it means to be mutually exclusive, or the opposite of that, I guess, would be not mutually exclusive. Mutually exclusive events mean that when two events cannot happen at the same time. Mutually exclusive. Two events cannot happen at the same time, and we'll see some examples of that in just a little bit. So let's start off with this discussion of dependent versus independent events. Your first four problems on the assignment will be this kind of activity. There are two events described, so let's look at letter A. The first event is spinning a spinner, and then the second event is selecting a marble from the bag. Well, obviously, spinning a spinner has nothing whatsoever to do with the outcome of selecting a marble. So this is an example of what it means to be independent. These are independent events. Now, understanding independent, dependent will then help you take the next step in actually calculating the probability, which will be next. But it is important that you understand what it means to be independent versus, let's look at letter B. We select a marble from a bag. We set it aside, which is another way of saying we don't put it back, and then we choose a second marble from the bag. Well, this is called a dependent event. Because by not replacing my first marble, I have affected the probability outcome for my second choice. So the first action, the first event, affected the outcome of the second. Letter C, the first event is rolling a number cube. The second event, tossing a coin. Completely unrelated. The outcome of the first has nothing to do with the outcome of the second. So this is obviously independent. And then letter D, we pick a flower from a garden, and then we pick another flower from the same garden. So that is obviously an example of dependent events. The outcome of the first affects the outcome of the second. Well, now that we understand the difference between dependent and independent, let's talk about how we calculate the probabilities. So I've given you a little formula here that says the probability of these two events, I'm calling the first event A and the second event B, and there's a key word here you should really focus on. Do you see that word and? And in these probability problems will always relate to multiplication. You can always make a connection between, if you see and in probability, you're going to be multiplying these two probabilities together. And the same formula holds true for dependent events, but we just have to remember that that second event has been affected somehow by the first, so we've got to make sure we take that into account before we multiply. So let's take a look at how this formula works with letter A. We have this box of marbles with these three colors, And my first event is picking a marble without looking. I put it back, and then I pick a second marble. Well, this is key. Because of that little phrase, I have independent events. The outcome of the first is not going to affect the outcome of the second since I put my first choice back. And so all I have to do to find the probability is, I'm going to first find the probability here. The probability is, what's the likelihood that I'm going to get a blue with my first pick and green with my second? So let's find each. What's the probability of blue? There are 2 blues out of a total of 12. Reduced, that would be 1/6. My second event is green. What's the probability that I'm going to pick a green with my second pick? So I do that separately. And since I put the first marble back, I still have 12 to deal with. There are 3 greens, 12 total. Reduced, that's 1/4. So I take these 2 different probabilities, the probability of A and the probability of B, and I multiply them together. And you can leave for tonight, you can leave answers like this in reduced fraction form. You don't have to change them to percent. So I got a 1 in 24 likelihood that my first pick will be a blue and my second will be a green if I replace the first one. Well, let's contrast that with letter B. Same box of marbles. We pick a marble the first time. So according to this, we're going to pick a green. What's the likelihood we're going to pick green? But before my second pick, I noticed that I set that first one aside. I did not replace it. So this is called a dependent event here because my second outcome has been affected by my first. So I'm going to do the probability of green, which we did earlier. That's 3 out of 12. Or 1/4. Then I'm going to do the probability of red, remembering that I did not replace that previous pick. So now that alters the probability of red. There are 7 red, but now I only have 11 marbles to choose from. And obviously I can't reduce 7 over 11. So I take these 2 probabilities, the green probability and the red, and I multiply these together. So the probability, the way you calculate it is the same. You're still multiplying, but for dependent, you just have to make sure you take into account how the first choice affected the second. So my final answer here is 7 over 44. Any questions on independent versus dependent, how to calculate the probability? Follow this little formula and you'll be good. This is what you're going to do on problems 5 through 9 in just a little bit. Okay, let's move on to another topic. What does it mean to be mutually exclusive, and then the flip side of that coin, not mutually exclusive? So I gave you earlier the definition. Mutually exclusive means that 2 events cannot happen at the same time. So here's a classic example. I roll a number cube. Is it possible with one roll of a normal number cube to get 4 and 6? That is impossible to do. So this is an example of what it means to be mutually exclusive. These cannot happen at the same time. Well, let's take a look at a not mutually exclusive example. With one single roll of a number cube, is it possible to get an even number and also that same number be greater than 4? What number have we just described? 6. Well, this is what it means to not be mutually exclusive, because that one roll, that one number can be described in both of these ways. Okay? So in problems 10 through 12, you're just going to be reading some scenarios, and it's going to be up to you to decide does this represent mutually exclusive events or not mutually exclusive events? So let's take my first example here, rolling an even number. Okay, so you might just go ahead and list those out. We got just number cube, numbers 1 through 6. So rolling an even number, obviously that would be either 2, 4, or 6. Okay, or rolling a number greater than 5. Well, the only number on the number cube greater than 5 is 6. Well, we have a number that fits both of those descriptions. So we're going to say that this is not mutually exclusive. And then when you get to these problems, tell me the reason. And it doesn't have to be anything elaborate. The number 6 is both. It's even and greater than 5. Okay, my next example, rolling a prime number. All right, so remember the prime numbers on the number cube, they start with what? 2. 1 is not prime. What's the next one? 3. Next one? 5. And for the number cube, that's all we have. Okay, let's jump over here. Multiples of 6 on the number cube. You know what the multiples of 6 are? The multiples of 6 are 6, 12, 18, 24, 30, 36. They start with 6 and then you just add 6 each time. So how many multiples of 6 are there on the number cube? 1. It's the number 6. So do we have any numbers that appear in both? We do not. So this is considered mutually exclusive. And if for an illustration or an explanation, you could say there are no prime numbers that are multiples of 6 on the number cube. Okay? Well, let's talk about, now that we can identify the difference between mutually exclusive or not, let's talk about how we calculate the probability. And you notice a key word difference? For dependent-independent, we had the probability of 2 events connected by the word and we connected the word and with what operation? Multiplication. Well, when you see the word or, that's going to be a clue for you that that's going to involve addition. And multiplication, or addition. So let me give you, first of all, does my letter A represent a mutually exclusive or a not mutually exclusive scenario? I roll one time, the probability of 4 or 6. What do you think? Yeah, there's no way for one roll to show both. We talked about that earlier. So here's how you're going to calculate probability for mutually exclusive events. I'm going to say in general, the probability of A or B is going to be equal to the probability of A added to, remember or is always connected to addition, added to the probability of B. So let's just take each probability separately. What's the probability that I will get a 4 with a roll? Well, there's 1 4 on the cube, and there's how many numbers on the cube? So that's a 1 in 6 probability. Now do the probability of getting a 6. 1 over 6. And all I have to do now is just take those 2 separate probabilities and add them together. And make sure you reduce if you can. Now that's for mutually exclusive. There is no possible way for both of these to happen at the same time. Well, let's take a look at letter B. You roll a number cube one time. What's the probability that with one roll you will get an even number or a number greater than 4? Mutually exclusive or not? Can you think of a number or numbers that could be classified in both ways? The number 6. So this is not mutually exclusive. And the way we calculate probability for not mutually exclusive is very similar. Very similar. In fact, it starts off looking exactly the same. We do the probability of A. We add the probability of B. But then it gets different. There is a huge difference. No pun intended. Actually, it is intended. I'm going to subtract. Difference. Subtract. Get it? I'm going to subtract that probability, and I'm just going to call it A and B. That probability, in this case, you mentioned one number that can be described in both of these ways. So there's one number out of how many? So I'm going to be subtracting 1/6 after I do the addition of the two probabilities. So let's just go ahead and do it. Let's do the probability of even number. How many even numbers are there? Yep, 2, 4, and 6. So that's 3 out of 6. And what's the probability of a number greater than 4? 2 out of 6. That's the numbers 5 and 6. Okay, so I'm going to do this part. I'm going to add those two together. 3, 6 plus 2, 6. And now I'm going to subtract that one number out of 6. There's only one number that can be classified in both of those ways. And that has to be subtracted off. So 3 plus 2 is 5, minus 1 is 4, and reduce. So my answer is 2/3. Okay, let's take a look at letter C. Tell me, let me get Landon. I toss a number cube. What is the probability of even or prime? Can you tell me whether or not that will be mutually exclusive? Are there numbers that can be considered both even and prime? What do the prime numbers start with? 2? So yeah, so would I call this mutually exclusive or not mutually exclusive? Which one? Not. Okay, so let's do the probability of even. And we did that earlier. That's 3 out of 6. The probability of prime. So what are the prime numbers on the cube? 2, 3, and 5. 3 numbers out of 6. And Landon said that there's actually one number that can be described in both of these ways. And that's the number 2. So I'm going to say even and prime. So I add these two together, 3 over 6 plus 3 over 6, and then I subtract the one that is both. And I end up with 5 out of 6, and that can't be reduced. And so we're done. Dependent, independent, mutually exclusive, not mutually exclusive. That's the focus of today's lesson. So I think I've given you a lot of examples, or enough examples. Your homework handout is on Moodle, just like last night. It's ready for you. If you don't have your device, I'm going to project up on the board so you can see it up here as well. So we're going to take the rest of the class time and see how much of this we can get finished.